quickly go over the solutions for the 3 novice problems from last week. So the first one we have is board reader. So the problem that we have is that it gives us some lines of text, and it wants us to print them all backwards in a single line. And the reason this might be a bit more difficult is because, first of all, we don't have a number at the beginning telling us how many lines there are, so we have to continuously keep on reading until there's no more text. And secondly, it's not that we're just reversing each line, we actually have to reverse the entire text. So as you can see in the sample input, the last word is Badoop, and the very first word on the first line is Badoop. So in essence, we have to reverse the entire thing. And now the reason we can't just use normal arrays to solve this problem is because we don't know exactly how many lines we're going to have, and it's very difficult for us to use arrays if we're not aware of how many slots we're going to need. So as a result, the one thing we can try using is array lists, because an array list works just like an array, except for the fact that we do not need to know how long it is. So what we're going to try to do is we're going to put each individual word into an array list. So the word in the first slot will be the, then fitnessgram, then pacer, then test. So each individual word will take up an index in the array list, and then we'll print out our array list backwards. So let's get started with the implementation. So the first thing we're going to do is declare our scanner, and I call mine KB, so yeah, but we can call our scanner, declare a scanner to read from system.in. After that, we know that we're going to have an array list to store all of the individual words. So let's make array list integer words is a new array list. Because we're storing strings, not integers, not that. And now let's sort of think about how we can fill up our array list with the given words. So one useful sort of command that scanner has is the while scanner.nextLine command. And what this lets us do is our scanner will continuously read until it sees that there is no more text in the next line. And this is really helpful because unlike in most problems, we don't have a number at the beginning telling us exactly how many lines of text we're going to have to read. So we can use this scanner command to make our lives a bit easier. Next, let's declare a string, let's say string x, to be the next line in the input that we're given. So string x equals kb dot next line. Also, whoops, sorry, this is supposed to be while has next line, I think. Wait, is this the correct? Oh, whoops, sorry, it's just supposed to be has next line, sorry. Yeah, so while has next line, let's declare our string x to be the next line. And since we want to have each individual word written backwards, not just the sentences in reverse order, what we're going to do is we're going to split the string x into an array using the .split command. And this really helps us because it splits up the text into individual words, so we don't have to manually sort of split it up ourselves. So let's say that string, let's call this array r is equal to x dot split, and we split based on spaces. So if you've never seen what the .split command does, if we give it a string, what it's going to do is it's going to, as you can see here, we've inserted a space. And what it's going to do is it's going to split up the text into array elements based on that space. So for example, if we gave it this first line, the fitnessgram pacer test, then what it would do is at index 0, we would have string the. At index 1, we would have string fitnessgram. At index 2, we would have string pacer, and so on, because we're splitting based on spaces. So for example, if we put something, what it would do is the array would be split based on the positions of commas. So now we know that our array R will store each individual word in a line. And now all that we have left to do is add it to our array list so that we can have a continuous running memory of exactly which position the words are in. So we can do for every string in the array R, we add the string to our array list. So words.add str. And now we're going to add every word in each line into our array list, which is why we need this for loop, because we take each word from the array and put it into the array list. So now we're done with adding, we're done with reading the input. So our array list words has contains every word that is in our sample input. So now all we have to do is print it out backwards. And we can do this by using a normal for loop. So for int I is equal to words.size -1, I greater than 0, I minus. And the reason we start at the back of the array list is because we want to, and from here, all we have to do is system.out.print. We just print out the word itself. So words.get I. This returns the word at position I, and we add on a space. Excuse me. And yeah, that should be our implementation for problem 1. So let's quickly see if this compiles. Hopefully there are no compile errors. Okay, it passed the sample. So let's see if it passed all the test cases. Yeah, and it's good. So before we continue, does anyone have any questions? All right. I'm going to assume no one has any questions then. Oh, and by the way, if at any point when I'm explaining you're confused about something I did, or you have a question about like the motivation behind the solution or something like that, then you can feel free to interrupt me, because there's a good chance what I said doesn't make sense, and I'd be happy to elaborate. So now let's move on to the second problem, which is on rotating a matrix. So what this problem is asking us to do is, if given a matrix of numbers, so in sample input 0, we're given the matrix 1, 2, 3, 4, 5, 6, it wants us to rotate it 90 degrees clockwise. So if you can imagine this 3 by 2 set of numbers, and imagine rotating the rectangle 90 degrees clockwise, then you can see that what we'll get is the sample output. And for those that don't know what a matrix is, a matrix is basically an array of arrays. So while an array stores numbers like in a list, so for example, an array could store the numbers 1, 2, 3, 4, 5. What a matrix does is it stores the numbers in 2 dimensions. So for example, if we have a 5 by 5 matrix, the first row could have 1, 2, 3, 4, 5. The next row could have 6, 7, 8, 9, 10. And then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then the last row could have 21, 22, 23, 24, 25. So you can just think of a matrix as like a 2 by 2 grid of numbers, whereas an array list would be a single dimension list of numbers. So now let's think about how we're going to do this problem. So unlike in the other problem, we are given the dimensions of the array, and this will help us in reading the numbers. So once we finished reading these numbers and adding them to a matrix, we have to think about how we're going to be outputting the numbers so it looks like it's been rotated clockwise. And looking at this, we can see that if we start at the bottom, if we start at the first element of each row and start at the bottom, and then we print these. So for example, the first element of the last array is 5. So let's say then we would print 5. The first element of the second to last array is 3. So then we print 3. And the first element of the third to last array is 1. So we'll be printing 1. So we can kind of see that instead of physically rotating the array, we can do this clever trick where we start printing from the bottom of the array. And if we print the numbers correctly, then it will look like we have rotated the array. So let's get started with the implementation. So as usual, the first thing we do is declare our scanner. Equals new scanner system.in. And next, let's declare our matrix so that we can store the numbers given. So let's say int matrix equals, oh, whoops, we can't do that. Since a matrix is an array of arrays, we have to know the dimensions beforehand. So we have to read these first two numbers in before we can do anything else. So int, let's say x equals kb.nextint, and the same for y. And x and y are now the dimensions of our matrix. So we can say that, so now we can finally declare our matrix as int matrix is equal to new int, and we can make it an x by y dimensional array. Wait, actually, I think it'd be easier to make it a y by x dimensional array. Wait. Oh, wait, no. Okay. So now we've declared our matrix. So let's read the input to put the numbers into our matrix. So the first thing we do is declare a for loop, which says for I equals 0, I less than x, I plus plus. And what this does is, since we know that the first one is x, so in the sample input it would be 3, we can see that there must be 3 rows to our input. So this for loop just sort of goes through each row. So then now, since this for loop goes through each row, we have to write another for loop to iterate through each column. So we can now use a for loop. So for int j is equal to 0, j is less than y, j plus plus. And the reason this iterates through columns is because we're given that the second number in this sample, the second number in the input will be the number of columns in our matrix. So we can write another for loop here with j equals 0, iterating to j less than y to give us the number of columns. From here, so now since the outer for loop iterates through the rows and the inner for loop iterates through the columns, then we technically have specified an exact number to input. So what we can do is matrix ij is equal to kb.nextint. And if we sort of look at this, if we just go through, so for example, since I starts at 0 and j starts at 0, then we would get that matrix ij is equal to the first element, and then j would increase by 1. And in doing so, we would have matrix 0, 1 is equal to the second element, which would be 2. And then afterwards, the matrix will just sort of iterate throughout. So that is how we will be reading the elements into the matrix. So matrix now stores all the values that have been given to us in the sample input. So all that's left to do is think of the way of how we're going to be printing this out. So it looks like we have rotated the thing 90 degrees clockwise. And we notice that in the sample input, we start in the bottom left corner, then go up, and then we go to the next column, again starting at the bottom, and then go up, and so on. So we can see that every single time we will be starting in the first row, sorry, we'll be starting in the first column, but the last row. So now let's write some code to implement this. So again, we start with the outer for loop, which is going to iterate through each of, this time the outer for loop will first iterate through each of the columns, because when we're printing things out, we can see that what is changing in each line is the row, not the column. Because since we're printing out 5, 3, 1, each of the numbers 1, 3, and 5 are all in the same column, but they're in different rows. So this means that the inner for loop will be changing the rows, while the outer for loop will be changing the columns. And we know that since the outer for loop is changing the columns, and we have y columns, then we can do for int I equals 0, I is less than y. Next, let's do for int j is equal to 0, j is less than x, because that is the number of rows we have. And then, and the other thing to note is that this should be starting at x minus 1, and then greater equal to 0, because we start at the very last row, and we slowly move our way up. Whereas in the columns, we start in the first column and then go to the second column. And now all we have to do is print out the element that is at the specified location. With a space at the end, so matrix ij. And then finally, at the end of every line, we have to make sure to print out a new line. So we do system.out.print line. And that should finish our implementation for this problem. Oh, wait. let's see. Oh wait, sorry, this is supposed to be ji. Oh, whoops, I did not type that correctly. Oh shoot. Another out of bounds exception. Okay. Oh, whoops, this is supposed to be minus minus, not plus plus. Okay, and I passed the sample input, so let's see if it passes all the test cases. And it does. All right, and that is the solution to problem 2. So does anyone have any further questions about the solution?
Oh yeah. Could you print out? I mean, well, I can hear my echo. It sounds so weird. Like, could you copy and paste the for loop at the very bottom and then put it in the chat so I can like see it? Because that's what really got me confused. Thanks.
Yep. Okay. Wait, I'm assuming this for loop, correct?
Yeah, that one.
Yep. Okay. And I just put it into the chat. The formatting got a bit mixed up, but hopefully it still works. And yeah, okay. Are there any other questions that people have? Alrighty. If not, we will move on to the last problem, which is on a symmetric matrix. Oh, symmetrics matrix. Haha, haha. So this time, we are given an n by n matrix. So in this case, we have a 3 by 3 matrix. In the second sample input, we have a 5 by 5 matrix. And we want to determine whether or not the matrix can be reflected over the vertical line of symmetry, so the middle line, to get the same matrix. If so, we print out true. Otherwise, we print out false. And this is, so yeah. Looking at this problem, the first thing we're going to do is think about how we can read all the input in. And it's convenient. And the reason this is not too hard is because, first of all, they give us the dimensions of the matrix at the top. So the first number represents both the number of rows and the number of columns in our matrix. And then once we're done with that, we can just read in the matrix. We can read in the set of numbers into a n by n matrix, similarly to how we did it in the second problem. So that's how we're going to be reading in the data. And then the last part, which is kind of tricky, is determining whether or not there actually does exist a vertical line of symmetry. And one thing we might notice when looking at the problem is that whether or not there's a vertical line of symmetry just equates to whether or not this element and this element are equal, this element and this element are equal, or this element and this element are equal. So all of those have to be matching. And then, for example, if we look at sample input 1, we have to have that this element and this element must be matching, this element and this element must be matching, and then so on and so forth. Like these all have to be matching, this one has to match this one has to match this. And we might see that we don't actually care about whether or not these elements in a certain row match with elements in a different row. The only thing we care about is whether or not an element matches with the pair on the opposite side in the same row. So as a result, we can think of iterating through each row and checking of whether or not the element at index I is equal to the element at index n minus I minus 1. Because that checks if this one is equal to this and this one is equal to this, and we can iterate through every index of the array. So that might sound a bit confusing, but we're going to get started with the implementation, so hopefully it's a bit clearer when the code is written out. So let's get started. Once again, we start with scanner KB equals new scanner. Very interesting. Honestly, you can just copy paste that bit in, but it feels cool to type it out. And then next, we're given that the first integer is n, so let's read that. Int n is equal to kb.nextInt. Now let's declare our matrix. Let's call it matrix again, because we don't have any other really good names. New n by n matrix. And yeah. From here, we do, as we did in the previous problem, we read in the matrix by using a nested for loop. And one way you could do it is something like this. Then we say that matrix ij, is equal to kb.nextIn. So now matrix should store every value that has been given to us in the sample input. So, of course, we're left with the hard part, which is determining whether or not there exists a vertical line of symmetry. So but as I mentioned before, what we're going to be doing is iterating through every row and then checking if the element at index I matches with the element at n minus 1 minus I. So let's write that out. So since the individual checking we'll be doing is within each row, then we know that the outer for loop should consist of iterating through each specific row, because the checking function that we're doing is checking each column. So for int I is equal to 0, I less than n, I plus plus. So this will iterate through each row. And now on the inner, we're going to be doing something like this. And here we're going to be checking if the element at index ij is equal to the element at index I. Wait, this is rows, right? I'm pretty sure. Okay, yeah. Wait, hang on. Wait, I'm pretty sure the first one is rows. Okay, is equal to the index at element n minus 1 minus j. Then something happens, and since if at any point any of them are not equal, we know that there does not exist a vertical line of symmetry. We can set a boolean, like boolean checker, equal to, initially we can set it to true, but if any two are not equal, then we set the checker equal to false. And then at the very end, if the checker is still true at the very end of the for loops, then we know that there does exist a vertical line of symmetry. Know that there must not exist a vertical line of symmetry. So we print out false. And sort of just quickly going over what this function is if you're still a bit confused. So what this does is it checks that in every row, we have that the element at some position. So as you can see, the rows are both I, so the rows are both the same. The element in each row at every position is equal to its position flipped, because j and n minus 1 minus j are opposite positions. So for example, in the sample input, this is position 0 and this is position 4. So we can see that the element at position 0 must equal 5 minus 1 minus 0, position 4. So that's this position. And that is what this if statement will be checking for every single pair of these things. So let's run this code and see if this works. Oh, shoot. Oh, whoops, this is supposed to be new int. Oh, whoops. Oh, sorry, this is supposed to not equal, because if at any point we see that they're not equal, then we know that there does not exist a vertical line of symmetry. So which is why this works. Sorry, it's not supposed to be equals. And yeah, we can see that we have passed both test cases. So let's submit our code. See if it passes every test case. And it does. And that's the solution to the last problem. And I know I went through that last part kind of fast because I'm not sure. I feel like I've taken way too much time. But if anyone has any questions, then you can feel free to ask right now before we end off, and I'll hand the stage back to Victor.
All right, I think if there are no more questions, then we'll move on to this week's lesson. Thanks, Rich, for going over last week's problems. All right, so this week, we're going to be going over sets and maps, which are structures that are really important when it comes to doing competition and probably like every other thing that you're going to do in computer science. So we'll go over sets first, and then we'll go over maps, and then we'll go over a problem set covering both of these topics this week. Yeah. So what are sets, first of all? You can think of set as a collection that can't contain duplicate elements. So it's very similar to an array, but an array can contain two elements that are the same while a set can't. So if you have a set that has integers 1, 2, and 3, and you try to add a 3 into the set, the set that comes out is still 1, 2, and 3. And there are two types of sets. There's a tree set and a hash set. A tree set sorts the elements automatically, or like it sorts it as you add them. And a hash set is a set where the elements are not sorted or ordered. And so hash sets are generally faster than tree sets because if you think about it, every single time you add an element into the set, if it's a tree set, then you need to sort it every single time. While for a hash set, it's not sorted, so you can just add it. Because of that, generally you should use hash sets. It'll save you a decent amount of time when doing competition problems. This is how you create hash sets and tree sets. You'll see it's very similar to array lists. And so instead of putting array list, you put hash set or tree set, and then inside these brackets or these symbols, you put what data type your set's going to contain. So in this case, cars and sorted cars both contain strings. You'll see it's basically the exact, and you also need to import java.util. You just import java.util, the package, because hash set is a part of it. And this is how you would create a hash set or a tree set and then add to the set. So here we have hash set cars and tree set sorted cars. If we add Volvo, we add it twice for both of them, you'll see that at the end, both of them only contain one because it doesn't contain duplicate elements. And then obviously we saw how to add it in the last slide, but here, if you see that, you can see that if we add cars, if we add Volvo, and then we add Ford, and then we do the same with sorted cars, you'll see that what it contains is actually switched because sorted cars is a tree set. And so when you add the Ford, it reorders the set to make it sorted, while cars does not. A useful method for hash sets and tree sets or sets in general are the dot contains. And you'll see this is like this is a method of the collections. So like array lists also contain dot contains. So you can check to see if a set contains a certain element. So here you can see cars does contain 4. You can also remove an item using the dot remove method. So here we see cars, we added 3 different cars, and then we remove Volvo. And we'll see that when we print out cars, we get Ford and BMW. And you'll see that because it's a hash set, the order in which we added it is the order in which it's being displayed. So we added Ford, and then we had BMW after. And then there are some other methods in the set. There's dot clear. It just clears every single element from the set. Dot contains we talked about, which returns true if it contains a certain object. Dot size gives you the size of the set. And then these two methods are extremely important when it comes to sets, because usually when you're working with sets, you want to find like the union or the intersection. And so add all. So if you do a set dot add all another set, it basically takes other set and like takes the union of the set that you have in other set. And then retain all takes the intersection of set and other set. And so these two are both very useful. And there's another one that I don't have here, but remove all takes the difference of two sets. So if you do, it would be, instead of add all, it would be remove all. And so basically, if the set that you have is 1, 2, and 3, and other set in this case was 3 and 4, if you did remove all, after you do remove all, your set will contain 1 and 2 because it removes the 3, because other set contained the 3. Are there any questions about these methods? I don't have any examples for add all and retain all, but like it's just useful to know, especially if you want to work with like sets in general. Okay. And then the next thing we're going to talk about is maps. And so maps are basically, think of it like a dictionary. You have like an input and you have an output. So in this case, it would be keys and values. So if you give a map a key, it'll return the value that key is associated with. So a key is generally an object that you use to retrieve a value at a later date. And like sets, there are two types of maps. There's tree maps and hash maps. Tree maps, there is a specified way the elements are arranged, but it's not in any kind of specific order because it's sorted differently in tree sets. But hash maps don't have any guarantee the way the elements are arranged at all. So generally, if you're working with maps, you don't really care about what order it's in. You just care about having keys and values and having those inside the map. And so something to note about hash maps is that keys and values both actually have to be objects. And so, for example, in our previous one, actually, I didn't create one, but if you have objects of type string, you would put string inside of the hash map. But if you want to use primitive data types like integer, boolean, or character, you have to use their equivalent wrapper classes. And so all that means is you do capital integer, capital boolean, capital character, or the capital double. So use these rather than use primitive types. And so here is an example of creating a hash map and a tree map. You also need to import java.util. And so we have a hash map here and a string map. The first, there should be a comma here, but the first input is the key, like the key type, and then the integer here is the value type. And so for both of these, the keys would be strings. So for example, it would be names, right? So like I could add a element to tree map that has a key of Victor, for example, and then the value would be 5. And then that could be like, I don't know, the number of dogs he has. So that's how you create a hash map or a tree map. And then a couple of methods useful for maps is the put method, which is basically the add method for array lists. It allows you to add a key and a value. And so you have this hash map called capital cities, and it takes in strings and outputs strings. So the keys are strings and the values are strings. And so you can put England as the key, and then the value would be London. And then here you have Germany and Berlin. And so if you look at this, like obviously it would be, if you wanted to find out what the capital of what the capital city is, then you would first put the country, and then it would the value it would output would be the capital. And so if we printed out capital cities, you can see the output on the right here, and you'll see there's no real kind of method to how it was added into the map. And then you can also remove items from a map. For example, you can put, like, for example, if I put 3 countries and there's capital cities, and then I remove England and London, then what outputs is the remaining keys and values. And so you'll see, and if it doesn't contain this, then it'll output an error. And a couple of other methods for maps. There's clear, which is very similar to sets. It removes all the elements from it. There's key set, which takes all of the keys and returns it as a set. So in this case, it would return England, Germany, Norway, and USA as a set. Contains value, basically checks to see if in the map there is a value of that type. So for example, if you had a phone book that you were creating, right, and the values were all phone numbers, and you wanted to check to see if your phone number was inside of that map, then you would do contains value, and then you would put your phone number, and it would return true if a value in the map is equal to what you put. Contains key does the same thing, but with the keys. So for example, with the phone book example, if the keys were names and the values were the phone numbers, if you wanted to find out if your friend William, for example, was inside of the map or inside the phone book, then you could do dot contains key, and then you would put William, and then it would return true if a key in the map is equal to what you input. Oh, another thing is that dot remove, if it's not here, it doesn't actually output an error. Nothing just happens. So, yeah. And then finally, you have the replace method, which lets you replace an old key or a key's old value with a new value. And so you can replace, for example, if your phone number updated, you can place your name, and then you can replace your old number with a new phone number. So these are some useful methods used in used for maps. And a couple of other things, just in general, why you would want to use, for example, tree sets over like array lists, is that oftentimes it'll take less time to add or remove an object to tree sets compared to compare to like other kind of collections. And so it's generally easier if you use, or it could save a lot of time, and you could pass a lot more test cases if you do competitions, you do tree sets, stuff like that. Are there any questions about what we went over? No? All right. I'll post the link to the practice problems in the chat. Oh shoot, there's a question. What do you mean by giving the map a key and having it return a value? Arnon? Oh, okay. So yeah, so you would use the get method in that case. So in that situation, like if I had capital cities and I wanted to get the capital of the United States, I would do capital cities dot get and then United States, and then this would return the value for the key that you put in the parameter. Does that make sense? All right. Yeah. Are there any other questions? Okay. I'll post the problem set in the chat, and then we have 5 minutes. I'll go over